And I'll teach you a shortcut with these, okay? So remember, these are, if you have the roots and you're working backwards to get the equation, this is the homework that was due today. When you have square roots and they are opposites, there's a shortcut that you can use. So I'll show you how to do it, okay? So I'll start with 2 because it's just the 2 of them. Your numbers might not be the same, but they're the same concept, right? So if I had 5 plus root 3 and 5 minus root 3, then when I write those out, it'd be x minus 5 plus root 3, and then x minus 5 minus root 3. So that the negative is going to distribute to both. So I'd get x minus 5 minus root 3 and x minus 5 plus root 3. Okay, and then I would normally FOIL that out. So the shortcut is when you have roots that have square roots and they have opposites, that you can actually FOIL out the rational part of it, the part that has that does not have the square root. So I can take that, which is x minus 5 squared, and then subtract from it the number that's underneath the square root. So I'm going to bring this down, and I'm going to say minus 3. So if you use the perfect square trinomial shortcut, you square the first term, you square the last term, and that's the last term. And then if you multiply those 2 terms and double it, which would be a negative 10x, that's your middle term. So you can do it that way as well. If you don't, then you just expand it and FOIL it out. You'll get the same thing. And then from that, you're going to subtract that last number, which in this case is 3. So you'd get x squared minus 10x plus 22. So that works only if the roots of those square roots are opposites. One's got to be a plus in between, one's got to be a minus in between. But it is a shortcut. And then a web assign gave you the f of x, but remember that your test is not going to give you the f of x. And you're providing a function, so you have to make sure that you add that f of x on. You don't want to lose a point for something silly like that. Then let's go to the second one. So I'll do the same thing with this one. This time, I've got 2 irrational roots, and then I've got a real root, or a rational root. So I get x minus 3 times x minus 8 minus root 5 and x minus 8 plus root 5. Again, opposite, so I can use the shortcut on these. I do x minus 8 squared minus 5. So I get x squared minus 16x plus 64 minus 5, x squared minus 16x plus 59, and then times x minus 3. So I still have to multiply that one out. So then I distribute the x to each of the terms. In the next one, I get x to the third minus 16x squared plus 59x. And then I distribute the negative 3 to all of them. Negative 3x squared plus 48x minus 177. And I get x to the third minus 19x squared plus 107x minus 177 equals f of x. If you're unsure about the shortcut or you haven't practiced it enough, then you just expand and FOIL them out. Remember, when you FOIL them out, I'm always going to take the ones that have the square roots on them first, because if I multiply those opposites, they're going to cancel my square roots out, and then it makes it easier from there on out. Don't do x minus 3 times x minus 8 minus root 5 and then multiply it. That's a lot of extra work you don't need. You want those to cancel out. This is another number, what is it, 3? This would have been x minus 7, and then if I use the shortcut, I'm going to do x minus 5 squared minus what's underneath the root, which is 2. So I get x squared minus 10x plus 25 minus 2, which is x squared minus 10x plus 23. And then I'm going to multiply that times x minus 7. So distribute, I get x to the third minus 10x squared plus 23x minus 7x squared plus 70x minus 161. And I get x to the third minus 17x squared plus 93x minus 161. So if you're not comfortable with a shortcut, then expand and FOIL it out, okay? But if you are, obviously, it's going to help you save some time. All right, so now we're going to finish 2-3, which is polynomial and rational functions. So I'm just going to go through what we talked about yesterday, which was long division. I said it yesterday, but I'm going to say it again. You are going to be forced to do long division on your test. So there is going to be a question that you're dividing by something that is not raised to x to the first, and those you're going to have to use polynomial long division. And you get options when it comes to stuff like this. So if it's asking if something's a factor, then you can use synthetic division to prove the division algorithm. That is your choice. Obviously, if you have the option, I would recommend using synthetic division, but you definitely want to be prepared for both. Okay, so we left off here. This one says divide using synthetic division. So remember that your first step is to take every term in the top, make sure it's in decreasing degree order, make sure you're not missing anything. I'm not, so I'm going to write out my coefficients. 3, -5, 7, -8. Then I draw my box, and on the outside goes what? +4, right? The opposite of what follows x here. I bring down the 3, I multiply it, I put it in the next column, which is 12. I add, I get 7. I multiply it, put it in the next column, 28. I add 35. I multiply it, I put it in the next column, 140, and I add, and I get 132. This is my remainder. Working left, the next one is my constant, then gets the x, then gets the x squared, and I would keep going till I ran out of numbers. So my answer here is 3x squared plus 7x plus 35 plus 132 over x minus 4. Everybody good on synthetic? Because again, you're going to use it a lot. Okay, the remainder theorem says that if you're given a function, f of x, what equals whatever, and you want to find f of 2. So if I had given you this prior to today and I asked you to find f of 2, what would you normally do? Plug in 2, right? So the other option is this. You can actually use synthetic division with the value inside without changing the sign, because this time you're saying that is x. You're not saying x minus 2. Okay, you're saying that is x. That number goes on the outside of your synthetic division. You do synthetic division, and the remainder is actually the answer if you had plugged it in. So this is another way to do something like f of 2. You do the 2 on the outside, you work through your synthetic division, you only look at the remainder. The remainder would be the same answer if you had plugged that 2 in, okay? So this says, use synthetic division and the remainder theorem to find the indicated function value. So I'm going to look at my initial function. Am I missing anything? What am I missing? A 0x is going to get plugged in there. So my coefficients are 3, -5, 0, 1. What's going to go on the outside? 2. Remember, this time you don't change the sign because it's actually saying x is 2. Bring down the 3. Multiply, put it in the next column, add it. Multiply, put it in the next column, add it. Multiply it, put it in the next column, add it. And 5 is the answer for f of 2. So just the remainder is your answer for these. When it's something like 3x to the third or something x to the fourth, this is probably easier than plugging it in, okay? You can do either way unless it says use the remainder theorem, then it wants you to use this method. So in the homework, I think it says use the remainder theorem. Practice it this way so that you know what to do. Questions on that one? Okay, the factor theorem says let f of x be the polynomial, if f of c equals 0, then x minus c is a factor of f of x. So if the remainder I get by using synthetic division is 0, then that number is called a factor. And when you list the factors, you do it like we did with yesterday's stuff. You put it behind an x. B says the opposite. If f minus c is a factor, then f of c is 0. So either way, you're saying if the remainder is 0, then the number that I use is a factor. If the number that I use is a factor, my remainder should be 0. So for these kinds of questions, I'm going to give you one solution, and it's going to say use synthetic division to reduce the degree of the initial polynomial, find the quadratic, and then find the rest of the factors by factoring what's left. So it's just going to say verify or show that the number provided is a factor. You're going to do synthetic division, show that the remainder is 0. By doing that, your answer, your quotient, is actually reducing your initial problem a degree, which makes it squared, and you know how to solve squared. You can either factor it, you can do the quadratic, all of those things, okay? So it says solve the equation x to the third minus 7x plus 6 equals 0, given that 2 is a 0. So notice that right now it's x to the third. After I've reduced it once, it's going to become x squared, which is my goal. So I'm looking at what's there. Is there anything missing? This time the x squared is missing, so I'm going to add that in. So my coefficients are 1, 0, negative 7, 6. What goes on the outside? Positive 2. Good. It's not saying x plus 2. It's saying that 2 is the 0. Bring down the 1. Multiply it. Put it in the next column. Add it. Multiply it. Put it in the next column. Add it. Multiply it. Put it in the next column. Add it. If it says it is a 0 or a factor, then your remainder should be 0. If not, you did something wrong or there's a typo on my end. Hopefully it's on you. Okay? If it's not 0, then something's wrong because we just said this is a factor. So now I'm going to take what's left, my quotient. Remember the 3 doesn't have an x, the 2 has an x, the 1 gets an x squared, and I'm going to write my polynomial, which is x squared plus 2x minus 3. And then I'm going to find my remaining factors. How do I do that? Can you factor that? Yes. Factors of negative 3 that sum to positive 2. Positive 3, negative 1, and my remaining roots are 1 and negative 3. Now it says solve, which means I need to give all the roots. So I have 1, I have negative 3, but I also have the 2 that they originally gave me. Usually it will list them like in order, negative 3, 1, 2. But you have to make sure that you include the first one because that is one of your zeros. Good so far? Yeah? Now it builds. Verify the given factors of f of x. Find the remaining factors. Use your results to write the complete factorization and list all the real zeros. So here is my initial function. And this time, I'm given 2 factors. So you actually have options here. You can use synthetic division with negative 2, and then use synthetic division with 1. I'll show you that process. So my first 0 here is negative 2, and my second one is 1. I can put the negative 2 on the outside. I'm not missing any terms this time, so it's 2, 1, negative 5, 2. Bring down the 2. Multiply, put it in the next column, add it, multiply it, add it, multiply it, add it. That's verifying that negative 2 is a factor. Now, if negative 2 and 1 are both a factor of the original and I reduce it a degree, 1 is now a factor of my new polynomial. So instead of going back to the beginning, I use these numbers as my coefficients, and I put 1 on the outside. Bring down the 2. 2, negative 1, 0. Again, showing that that is a factor. And what's left is 2x minus 1, which means my last root would be what? 1/2. So my roots are negative 2, positive 1/2, and 1. That's actually part D.
Would it matter which one you use first, or you can...
Nope. Yep, doesn't matter. If 2, let's say 20, right? So if I say that 2 is a factor of 20. If I reduce that and I put 2 into it, it's still a factor. It's going to continue to still be a factor. So even if you had 2 of them and you reduce them, it's a factor of the original and it's a factor of the reduced one. Yeah, so the order there doesn't matter. Your other option, should you choose to do it, I don't know if I would, but should you choose to do it, is you can actually FOIL out these two. I'd get x squared plus x minus 2. And then you can use long division on the original one, and you will get 2x plus 1, or 2x minus 1. You'll get the same quotient. You can do that. That's your option. I wouldn't say you need to do that. Okay, I probably wouldn't recommend it, but you can do that as well. You can FOIL out the two that were given to you, and then use long division with your original, and the quotient would be 2x minus 1. Okay, so, but B said find the remaining factors. So factors are different from zeros. Factors are going to be written in expression format. So my factors are x plus 2, x minus 1, and then the thing I had before I set it equal to 0, which is 2x minus 1. Or I could say x minus 1/2, but you can't have a fraction in there. So you'd multiply by 2, and you'd get the 2x minus 1. So no fractions in your, they'll actually use the word linear factors, which is what that means.
So that's for part C?
This is B. Well, the remaining factor is this. Oh. This is B. C says complete factorization. That's all of them. D is the zeros. Okay, so again, remaining factor is the 2x minus 1. That's B. The complete factorization is all three of them in any order. 2x minus 1, x plus 2, x minus 1. And D is all the zeros and zeros we list. Negative 2, 1/2, and 1. Questions so far? So sometimes you'll see where they just give you one of these. You'll reduce it a degree, and then you'll factor what's left like the last one. Sometimes they'll give you 2. You reduce it 1 degree, use the second one, reduce it another degree, and then you'll get the last remaining factor. All right, the rational zero test. So up until this point, you either had something that was factorable, or I gave you at least one root to start with so you could reduce it a degree and then factor it. What happens when you have no zeros given? You have to come up with a bank of possible roots and then test them until you find the ones that work. This is a tedious process. I'm warning you now, okay? It's a trial and error. This is also something you should remember from Algebra 2, okay? The possible rational zeros come from the factors of the constant, which if it's in order from greatest to least is the last, over the factors of the leading coefficient, which, again, if you put it in decreasing degree order, is the first. So this is the same thing as saying plus and minus. The factors of the last over the factors of the first. Those are possible rational zeros. These are not necessarily your zeros. They're just the possibles. Rational means no square roots. That aren't perfect squares. Obviously, like something square root 4 could work because that's 2. But if it said like square root 3, obviously those are not going to pop up in your possible bank. So then what you do is once you establish your possible zeros, you're going to use synthetic division until you find a 1 that's a 0. How would you know it's a 0? The remainder 0. And then from there, if it was started as x to the third, then you just reduced it a degree, which you can either factor or you can use the quadratic. All right, so this says list all the possible rational zeros of f of x equals x to the third minus 3x squared minus 4x plus 12. Find one of the zeros in the function using synthetic division, then factor the remaining polynomial. What are all the zeros of the function? How can the graph below help you find the zeros? So I'm going to start first with my initial function. Is it in decreasing degree order? Yes. What's the constant? 12. What are the factors of 12? 1 and 12, 2, 6, 3, 4. What's my leading coefficient? That's the degree. What's the coefficient on it? 1. So this is the degree. What's in front of that is the leading coefficient, which is 1. So that all goes over 1. This is plus and minus all the factors of the last over the factors of the first. So this means that my possible roots are -1, +1, -2, +2, -3, +3, -4, +4, -6, +6, -12, +12. Now we got to figure out which one works. So we start at the beginning.
Wait, is it also plus or minus 1 or no?
It's all of those over 1. So this goes over 1, this goes over 1, this goes over 1, this goes over 1. Because it's 1, it's just my numerators. If it was, let's say, there was a 2 here, all of those would go over 1, and then all of those would go over 2.
Oh, no, I mean like for the leading coefficient, do you also make it negative? Or
No, the plus and minus, last over first, takes the negative for each of them. That's why it's plus and minus. So you don't need to, is that what you're saying? Like 1 could be 1 and 1 and, or -1 and
like if you
-1?
put everything over -1.
It's
only
you
do it
already
for
have the
number.
plus and minus, so you don't need it.
Okay.
Yeah, as long as you put the plus and minus at the front, which means you're gonna get each one, you don't need them both.
Okay.
All right, so I'm gonna do my synthetic division, right? 1, -3, -4, 12. I'm starting with 1. This is why you want to get fast at it. Doesn't work, so I go to -1. Doesn't work, so I go to 2. God bless you. And that's the first one that works. So I know 2 is one of my zeros. Sometimes you get all the way to the end, folks. That's what happens, okay? Then I take what I just reduced a degree, which is x squared minus x minus 6, and I see if it's factorable. Are there factors of -6 that sum to -1? Yes, right? -3, +2, and my remaining roots are 3 and -2. So if I had kept testing my possible roots, I would have eventually seen that 3 worked and -2 worked. But you don't need to do that. You could get it to the point that you could factor it and factor it. So now when it says, what are all the zeros? It's -2, 2, and 3. And then it says, how would the graph have helped with this? How do you see zeros on a graph? X-intercepts, right? So right here is -2, right here is +2, right here is 3. Still with me? Yep. Mm-hmm. So the way in which you will actually see this on your test is this will be on the portion of your test that has to have the graphing calculator. But what will happen is there's only going to be one rational root and it won't be a whole number, okay? So what you'll do is you'll graph it. You'll see it cross the graph at some point that you can identify. And how would you identify those points if you had it on the graph? The zeros. You'll look for a 0 that matches one of your possible roots. You with me so far? Then you will use synthetic division with that root to show that the remainder is 0. Yeah, and you'll reduce it a degree, and you'll either factor or use the quadratic to find the remaining zeros. Does that make sense? So again, they're not going to be whole numbers that you can see from your graph, which means that your leading coefficient will probably not be 1. Okay, you'll get fractions. So if this leading coefficient was 2, then my possible roots would have been 1, 2, 3, 4, 6, and 12, all over 1 and all over 2. So you would have had 1, 2, 3, 4, 6, 12. Whoops. Plus and minus. But then you would have had 1 over 2, 2 over 2, which is still 1. I already have that. 3 over 2. 4 over 2, which is still 2, I already have it. 6 over 2 is 3, I already have it. 12 over 3 over 2, that's 6, I already have it. So then let's say from this bank, I looked at my graph. and I looked at my zeros, and one of my zeros was 1.5. Does that make sense? Then I'm going to use synthetic division with 3 halves on the outside. I'm going to show that my remainder is 0, and then I'm going to take what's left here and either factor it or use the quadratic equation to find my other zeros. Does that make sense? Yeah? Okay. Yep. Okay, so then I'm going to teach you 2 things that'll help you narrow down your zeros, okay? The first is called Descartes Rule. So Descartes Rule says that if you look at your polynomial, again in this decreasing degree order, then the number of positive real roots is either the same as the number of sign changes. So if I count from negative to positive, positive to negative, it's either that number or that number minus 2 until it gets to a 0. So if I count my sign changes and there are 1 positive sign change, then there is 1 positive root. If I count my sign changes and there are 2 sign changes, then there's either 2 or there's none, because they come in pairs. If it was 4, it'd be 4 or 2 or 0, again, because they come in pairs. So if I count my sign changes and there's, I don't know, 10, that means there's either 10 or 8 or 6 or 4 or 2 or 0 positive roots. To test for the negative roots, we first change the signs of x, just like we do for our symmetric test. We simplify it, and then we count the roots, or count the sign changes. And it's the same. It's either that number or that number minus 2 until I hit 0. So if there is 3 sign changes after I simplify, then it's 3 or it's 1. Negative root. Again, they come in pairs. Like the other roots would be imaginary, and those imaginary roots come in pairs. That's why you subtract 2. So look at my function. Okay, let's look at this one. The first one, if I look at the original one here, I want to identify my sign changes. So it goes from positive to negative, that's 1 sign change. Then it goes from negative, but it stays negative, no sign change. Negative to positive, there's another one. Stays positive. Positive to negative, there's a 3rd sign change. Everybody sees that, right? Which means there's 3 or 1, because I can subtract 2 from that. And this would be for positive roots. Now, if I want to count the negative ones, then I have to take my function, plug negative x in, simplify it, so every time it's odd, I change the sign, right? This would be negative 3x to the 7th. Every time, this would again be negative, so this is going to be positive 2x to the 5th. Every time it's even, that negative is going to go away. So there's still a negative on the front. This would be gone. This would be positive. Minus x minus 3. Then I count my sign changes. Starts negative, goes to positive, that's 1. Goes to negative, that's another 1. Goes to positive, that's another 1. Goes to negative, that's another 1, stays negative. So there are 4 sign changes, which means 4 or 2 or no negative roots.
So you have to start before, you have to start with the leading coefficient.
Yeah.
Okay.
So how is this going to help you? If it says there's 1 positive root, then when you go to test your positives, when you go to test your possibles, only pick the positives, because you know it's going to be positive. If you know that it could be 2 or 0, then maybe if there's only 1 negative, then you look at the negative numbers, because you know there has to be a negative root. So it's supposed to help you narrow down your possible root bank, okay? So this says, for f of x equals x to the 3rd minus x squared minus 4x plus 4, how many positive and negative zeros are there? Use a graphing utility to find one real zero of the function and what are all the zeros of the function. Put a big old star on example 9. This is on the calculator portion of your test. Not that question, obviously. Same process. And it actually, if you want to add positive. Is it number 10 on yours?
Yeah.
Okay, possible roots. So it's 10. Okay, add possible roots. Because your test is going to put them all together. So the first thing I'm going to do is all the possible roots. So this is plus and minus. Last over first. What are the factors of the last number? What are the factors of 4? 1 and 4, 2 and 2, right? So 1, 2, 4. Okay. What are the factors of the leading coefficient? Just 1. So you can simplify it and just do plus and minus, but I want them to be whole numbers. Or if they have a denominator, you need to split them up. Okay. So if that was a 1 and a 2, then you would split them up. With me so far? Okay. Then it says how many positive and negative zeros are there? So I'm going to my original function and I'm counting the sign changes for the positive. So it starts positive, it goes to negative, that's 1. It stays negative, and then it switches to positive, that's another 1. Which means, how many positive roots are there? 2 or 0. Then I'm going to plug in a negative x. This stays negative. This becomes positive, but there's a negative on the front. So that's negative, positive, positive. How many sign changes? One. How's that help you with your possible bank? If you had to try out all those possibles, which ones are you going to try first? The negatives, because there could be 2 positives, but there could be none. So I would start with all the negatives because you know there has to be a negative. Does that make sense? Yeah? Okay. All right, now it says use a graphing utility to find one real zero of the function. Now I'm going to go to my graph. I'm going to go to my y equals. I'm going to get negative x to the third minus x squared minus 4x plus 4. Graph. Oh, I'm so zoomed out, sorry. From the last example. All right, so you ever see? Yes. How do I get that 0? Is your graph different?
Did you use the original one or
Original. Did I do negative? Yes, I did. Now it matches. Yes. Mm-hmm. Yeah, let me get through this and then I'll go back to that. Okay, so now I need to find just one, and I'll tell you right now that on your test, they're not all going to be whole numbers. Okay, so you're going to find your zeros. So if I just pick any of them, I'm just going to pick one. I'm going to go to second trace, or second trace. I'm going to go to 0. I'm just going to pick that first one. And I get negative 2. So already I've got my 0, which is negative 2. So from the graph, the first 0 is negative 2. Okay. Then let's say those other ones are not rational ones. Okay. I can't factor what's left. What am I going to have to do with this? Synthetic division with negative 2 on the outside. And then 1, negative 1, negative 4, 4. Bring it down. My remainder 0 as it should be. And now I get x squared minus 3x plus 2. Oops. which is -2, -1. So my roots are -2, 1, and 2. Now this example was factorable from the get-go. I know that. Your test will not be like that. Okay? You will have one root that matches one of your possibles, and then you'll have to do synthetic division to reduce it, and then most likely quadratic because they're not going to be whole numbers, or factorable. Yep.
Is quadratic the negative?
Yep. So as soon as you get it to this point, you can, if you can't factor it, you can use quadratic. You can always use quadratic as long as you bring it down to the second power. Okay, so Gianna, the positive or the negative or both? So when I look at my original function, right, which was x to the third minus x squared minus 4x plus 4, I want to count the sign changes. So it has to go in decreasing degree order, which it is, right? It goes from positive x to the third to negative x to the second to negative x 4x plus 4. So starts negative, stays negative, becomes, no, sorry, this is positive. Starts positive, becomes negative, that's one sign change. Stays negative, but then becomes positive, that's a second sign change. So when I'm counting my possibles, it's 2, or if I can subtract 2 from that, I have to, which means or 0. That's positives. Then for negatives, we plug in a negative x. So I plug in a negative x, a negative x, a negative x, and I simplify, just like we did with synthetic. Then I count my sign changes again. There was only one sign change that time, which means there's one negative root. Questions on any of that stuff? Okay, so this thing is upper and lower bounds. Again, it's just to help you figure out to narrow down your possible banks. So if you divide whatever f of x is by x minus c using synthetic division, and the bottom row is all positive or 0, so your answers on the bottom are all positive or 0, then what you divided by is called an upper bound, which means there can be no root bigger than that number. There can be stuff smaller, but there can be nothing bigger than that root. If what you're dividing by is positive, so it has to be positive, the number on the outside has to be something like, I don't know, 2, you're dividing it in 1, 2, 3, all the numbers on the bottom have to be positive or 0, and if that's the case, then this is called an upper bound, which means no root can be bigger than that number. If the number on the outside is a negative number, and the pattern on the bottom is alternating, either positive, negative, or negative, positive, or a 0 to break up either of them, then it's called a lower bound, which means there's no number lower than that. This is only to help you, so I'm not going to test you on this, okay? This is only to help you narrow down your possible roots. For example, if I go to test a possible root and 1 is on the outside and my numbers on the bottom are all either positive or 0, then I know 1 is an upper bound and I'm not going to try anything bigger than 1. So I narrow down my bank. If I put a negative on the outside, like a -1, and my answers are alternating on the bottom, then I know that that's the lower bound. I'm not going to try anything smaller than it. So again, I'm not going to test you. It's not going to ask you for lower bound, upper bound. It's just used to help you narrow down your bank.
Wait, can you get like a 0 on the
Yep, and it doesn't matter.
So you just like skip it?
But the sign was so that counts as the sign change.
Okay.
So if it goes from negative to 0, then it should go to negative because it should be alternating. So this last example just shows you how to use them. It says use synthetic division to verify the upper and lower bounds of the real zeros of f. So with my upper bound, I'm going to take 1, put it on the outside, list my coefficients in decreasing degree order, 1, 3, -2, 1, use synthetic division. And show that all the numbers on the bottom are either positive or 0. That's verifying it's an upper bound, which means there would be no root bigger than 1. Doesn't mean 1's a root, because it's not. It didn't give me 0. It just means there's no root bigger than 1. And then the lower bound, I put the -4 on the outside. 1, 3, -2, 1. This is 1, -4, -1, 4, +2, -8, -7. Now I'm showing that they alternate. They go from positive to negative to positive to negative. That proves that -4 is the lower bound, and no number less than -4 is going to work in this function. Yep.
It's not alternating, so
It's not supposed to alternate. It's all positive or zeros for the upper bound. But your test, I'll even for a test review, but your test is covering everything we covered from the quiz, which was 1, 6 to 2, 2. And then we're adding on it 2, 3, which is your long division, your synthetic division, your using of the calculator to find a root. The other thing from 1, 6 to 2, 2 that was not on your quiz that will be on your test was, I told you yesterday, but it's like the quadratic word problem where you're going to have to graph a quadratic and then answer something. It's like the punt example that we did in class, okay? You're going to either have to say what happens if it's like, basically, is it a 0? Is it a max? That kind of thing. What's your intercepts? Those kind of things based on a function that has to be graphed on a calculator. So that and that last example 10 that we talked about, those are the two that are on your graphing calculator portion, and then the rest is without a calculator. Yep.
on the review, is there going to be a question with practice?
I think there is. Let me look on it. I'm almost positive that I put a word problem in there. I have to look on it. I don't know if it's on the original or the extra, but I'll look and make sure. Yeah. You want to be practicing, obviously, with your calculator on those and not on the other ones. Don't use your calculator when you shouldn't have it. I would just try to get a head start this weekend. Don't leave it all for Monday night. Take the time to look through your quiz. Bring it back with you on Monday so that if you have any questions on it, we can go over it. Pay attention to the format of your answers if you got points off on your quiz, because that stinks. If I could find your mistake, I tried to find it and circle it. But if I didn't and you need help, then class time Monday's review. Before school Monday's fine. After school Monday's fine. But you got to make sure you ask before you take this test. Okay? Questions? All right.